6.3 Applications of normal distribution. Now guys, sometimes the mean is not equal to 0 and the standard deviations is not 1. Well, we can use this formula up here to help us find the z-score. The z-score is going to be x minus the mean divided by the standard deviations. Now we round this 2 decimal places because in your book you have 2 decimal places for your z-score, right? So all of these will be rounded 2 decimal places. Now, let's say that there's a tall club. It's actually called Tall Club International. And has a requirement that women must be at least 70 inches tall, with a mean the mean women height is 63.8 inches and the standard deviation is 2.6. Find the percent of women that meet this height range. Okay, so they have to be 70 inches tall. The mean, which is mu, is 63.8, and the standard deviations is 2.6. Okay, so this is my x, 70. That's the height requirement. So to find the z-score, we're going to do 70 minus the mean, which is 63.8, and divide it by the standard deviations, which is 2.6. In solving that, we find out that the answer is going to be 2.38. Okay, now guys, that's everything to the left of 70. In other words, on our bell curve, if 70 were right here, it would be this over here. We need to know what women are that tall or taller. And so that doesn't tell us our answer, but let's find its probability still, because that's what we need. You're going to look for 2.3 on the rows and 0.08 on the columns and find out where they meet up, and you'll find out that that probability is 0.9913. With it being 0.9913, we then can find out everything greater than that by doing 1 minus 0.9913, and the answer is going to be 0.0087, which means the probability that a woman is 70 inches or greater is 0.87%. Okay? That's how that z-score works for us. So we can use this when our mean is not 0 and our standard deviations are not 1. Next, we have a lot of problems with height here. British Airways requires cabin crew must have a height between 62 inches and 73 inches. So basically, guys, the probability we're going to look for here is that they are between 63 inches and 72 inches and 73 inches. Okay? So that's the probability we're going to be looking for. Now, men's average height, or the mean, mu, is 69.5. And the standard deviations are 2.4. Now, since I have to find in between 62 and 73, what I'm going to do is I'm going to find the z-score for 62 and its probability, and find the z-score for 73 and its probability, and subtract them to find out between them. So, the z-score for 62, we're going to subtract the mean, 69.5, and divide it by 2.4, which are standard deviations, and that gives us negative 3.13. Alright, so we need to find out what that probability is. So we go to our chart in the book. We're going to look up negative 3.1, and then the column we're looking for is 0.03, and when they meet up, they give us 0.0009. Okay, next, we want to find the z-score for 73. 69.5, 2.4. Notice that those are the same. And when we solve this, we get 1.46. Now on the positive page, the row is 1.4, the column is 0.06, and that probability is 0.9279. Now because we're looking at the probability in between these, we're going to do 0.9279 minus 0.0009, and that gives us 0.9270. In other words, you have a 92.7% chance that a male is going to fit within that height range. The majority of males fit that range. Okay. With aircraft, there is a requirement that the height of the ceiling has to allow 95% of men to stand without bumping their heads. In other words, we're looking for the 95th percentile. Okay? We want to know the exact number or the height that is the 95th percentile of height. Now guys, a lot of this is going to be the same. The mean, which is mu, is going to be 69.5. The standard deviations are going to be 2.4, just like in the last problem. Now, what we want to do, guys, is basically we're looking for the 95th percentile, which is the area is going to be 0.95. We need to find the z-score so that we can find the percentage of that, okay? Now guys, we've already found the z-score of 0.95. You remember it's one of the special cases, and that z-score was 1.645. Okay, it's one of your special cases. So knowing the z-score is 1.645, what we're going to do here is we're going to plug it into this formula up here, but we're looking for the value of x, which means the height that it needs to be. So my z is 1.645. X is x, we don't know it, minus mu, which is 69.5. And then the standard deviations is 2.4. When we solve this, guys, we're going to multiply 2.4 over here. So we have 2.4 times 1.645, and what we have remaining here is x minus 69.5. Now in math class, you would learn that you will now add 69.5 over to this answer. Now you could have already solved this. I'm just going through the full thing. So x is going to equal 2.4 times 1.645. You have to multiply first. And then you're going to add to that answer 69.5. That gives you a value of 73.4 around it. So basically, the height of the ceiling has to be 73.4 inches in order for 95% of males to be able to stand without bumping their heads. Alright. I'm going to erase this so I have more space. Students are separated into the bottom 30%, middle 40%, and top 30%. A lot of teachers believe that if you separate them according to abilities, then they learn better. And so they're going to be separated into the bottom 30, middle 40, and top 30. Okay? Now, the mean for, this is their test scores. Okay? The mean test score is, I'm going to use this symbol for mean because we haven't been using it a whole lot, but we'll just say that the mean is 100 and that the standard deviations is 15. Alright, so we want to find out what numbers are separating these into their percentages. So let's draw this so we know kind of what we're looking for. We want 0.3% area. Let me write it in here, 0.3. We want the middle 40%, so 0.4 here. And then we want the top 30%. So basically, guys, what we're looking for is the values of x at those points there. So we need to find the z-scores and then use the z-scores to help us find out what x actually equals. Now guys, let me give us a formula here. This is basically what we did when in the last problem, only I'm going to give us a formula that actually just puts it straight. X is equal to the mean, or mu. In this case it's, I'll just write it the way they're doing it. Mu plus the z-score times your standard deviations. That's basically what we did in the last problem. This is just giving us a simpler way of looking at it. This is how we find out the value of x. So, for the point 3, we need to find out the z-score for point 3. You look in your book, you find the probability for point 3, and you're going to see that that is negative 0.52. That's the z-score here, okay? So, now, what we want to find here is 70% to this point. So we can do it one of two ways. We can do 1 minus 0.3 to find out what the probability, the probability should be, or whatever, or we can just do 0.7, and when you do 0.7, you find out that this is positive 0.52. So now I know the z-scores for those two spots, I just need to find x. So let's plug in the values that we know. For the first point, this one, our mean is 100, our z-score is negative 0.52, times our standard deviations, which is 15. We solve that, you multiply first and then add 100 to it, and we get 92.2. So that means this value here is 92.2. Next, we want to find this value here. So x is going to equal, again, 100 plus, this time it's positive 0.52 times 15. When we solve that one out, remember, multiply first and then add 100, you get 107.8. So the scores that break up the groups are these scores there. Okay? And that's it.